Hi guys, welcome to my YouTube channel Sri Swami Engineering Academy. Today we are going to discuss about flywheels. Now what are the flywheels basically? Flywheels are those mechanical components which stores the energy when it is in excess and it supplies the energy when it is required. Now why flywheel is needed anywhere? Let us see why flywheel is needed. Let us take an example of say engine. You might be knowing about the IC engines, that is 4-stroke, 2-stroke engines. Okay. Now, if in a 4-stroke engine or a 2-stroke engine, what happens actually? There are strokes like suction, compression, power, and exhaust. If you take an example of a 4-stroke engine, during suction, there is no power given by the engine. Then during compression also, there is no power given by the engine. Only power is given in the power stroke. Even in the expansion stroke, no power is given. That means what? You are getting the power only in the power stroke. Now remaining 3 strokes will not have any power. That means you have to supply the work to the engine to move the piston forward or backward. Now how it can be done? So in such cases, flywheels are employed. The flywheels will store the excess energy given during the power stroke and supplies that energy when there is a suction stroke, compression stroke and exhaust stroke. Now here again, if you take an example of say a punch press, let us say this is a workpiece and you see this is the slider. When the slider moves down, you will have a punch of a hole. This is a punch, there will be a hole. Okay. Now during this punching operation, what will happen? When you want to punch a hole, when this punch will be here and it will pass through the metal, it will require more energy than when it is moving up and down. That means in the other strokes, you don't require that much of energy. But during the punching of this hole, that process will require more energy. That means what? If you see the power source, if you are having a power source, let us say a motor is there, that motor will supply a constant energy. That means there is no such provision which will supply more energy when there is a punching. So in that case, if you attach a flywheel there, during other strokes, other movement, the flywheel will store the energy, and when the punching operation will be there, the flywheel will provide the energy. That is why the flywheel is needed. Okay. Now let us see something more about the flywheel. Now how the flywheel is working. Now how it will be done. Now let us say I will draw a turning moment diagram for a turning moment or torque, turning moment and crank angle diagram. You can say crank angle diagram for a flywheel. I will assume that there is an engine whose cycle completes in 1 revolution. 1 revolution means only in the 1 revolution of the crank the cycle will be completed. In case of say 2-stroke engines, in 4-stroke engines you require to complete 2 revolutions. 1 revolution means 2 pi. So let us draw a theta diagram, that is what turning moment and crank angle diagram. This diagram is nothing but the graphical representation of a crank angle move and a torque. Okay. So let us say here the theta or a crank angle is on the x-axis and torque T is on y-axis. Okay. Now if I draw a turning moment diagram, say let us say this is my turning moment diagram. This is my turning moment diagram. So I have drawn it for an example. This is a turning moment diagram. And I say, as I have already said, let us say this example is for the cycle which is completed within 1 revolution. 1 revolution means your turning moment diagram will end at 2 pi, and after that again the cycle repeats. That means this will be pi, that means this will be pi by 2, this will be 3 pi by 2. Okay. Now if you see here, its torque is going to increase. At this position, the torque is highest. So I can say that the torque is maximum at this point. This is the T max. T max. Okay. Now, if I say that this is turning moment diagram. Now generally if you see what is the work done is nothing but you can say it is T into theta. That is what? Torque into distance, angular distance moved. Okay, that is the work done. Now in this case, work done per cycle can be taken as torque into theta. Now here if you see, this is the variation of a torque. That means the area under this curve, total curve, is nothing but this curve area. This area is nothing but is the work done per cycle in this case. Okay, so area under the curve is nothing but the work done per cycle. Okay, now let us say that I have a average torque. Let us say I will take an average torque here, but it is very bit complicated to find out the area under this curve. Mathematical expressions are there to calculate, but for the simplicity, what generally we are doing is we are taking a mean torque. We are taking the mean torque. Let us say the mean torque is somewhere here. Okay, let us say the mean torque is somewhere here. This is the mean torque, or you can also say it is the average torque. Okay, so what we are doing is we are just doing like this. Just we are calculating the area under this rectangle that can be taken as work done per cycle. You see, if you see here, this is not the work done because this is the blank one. This is not area under the curve, but still it is taken in this rectangle. But if you see here, this area is not taken into the rectangle, but actually it is the work done. So that compensates. Likewise, this compensates, and likewise we can have the average work done per cycle from this diagram. Okay. Now this is what T mean, and this is the area under the curve. That means area under this rectangle can be taken as work done per cycle. Now here you can say what is the work done per cycle? That is nothing but this height into this length is nothing but the area of this rectangle. That is 2 pi into T mean is nothing but the work done per cycle. Now let us have the analysis of this diagram. Okay, so I will take certain points on this diagram and I will name it. Let us say this is A, this is A point. Let us say this is B point, C, D, E. Okay, I will stop here. The same will be going forward. Then I will take this as a I will take this one as like this. Okay, this is like this. This is like this. Now let us see here. E. Then this is say F. This is say G. This is say H. This is say I. Okay. Now what happens? Now, if I consider that the flywheel is moving from A to B. A to B means what? It is moving, that crank is moving by 0 to pi by 4. This is pi by 4. Okay? This is pi by 2, this is pi by 4. So, crank is moving from 0 to pi by 4. Let us say flywheel is moving from 0 to pi by 4. The flywheel looks like this, something like this. This is, say, flywheel. Sometimes the flywheel is the spoke flywheel like this, or sometimes it is like a disc. Okay, let us say like this. So let us say it is certainly at this position. This is pi by 2, and this is say pi, and this is say 3 pi by 2, and this is 2 pi. Now let us say it is moving in this direction, and let us say this is what, pi by 4. So now if you see here, when the flywheel is moving from A to B, that means what? That rotation loop is 0 to pi by 4. So from A to B, what happens? If you consider this rectangle, that is rectangle ABFO, okay? If you see this rectangle, okay, so this rectangle is nothing but the work required. This is called work required. ABFO is work required. So I will write here work required is area of ABFO. ABFO. Okay. Now what is the work done? What is the work done? So let us say work done here. Work done. Work done is nothing but the area OBF. This is nothing but the area under the curve. I am considering this rectangle only. That means this area is under the curve. So this area is nothing but the work done. If you see this, this area is work done. Okay. Now this area is nothing but say OBF. Okay. Now if you see here, the area OABF is more than the area OBF. It means the work required is more than work done by the engine. So you have to supply the work here, because this work is required, but only this much work is, this total work is required and this much work is done. That means you require this much extra work. Who will provide that work? Flywheel will provide that work. So if the flywheel is providing that work, that means what? The flywheel, when moving from A to B, its speed decreases. What happens? Speed decreases. Okay, that means when flywheel is moving from A to B, that means its speed go on decreasing, and it is at B. It is at a slower rate because energy is supplied by the flywheel. Now consider when flywheel is moving from B to C. So let us take theta from B to C. When flywheel is moving from B to C, what is the work required here? Now the work required is BCGF area. BCGF, this is the area. But what is the work developed or work done or produced? That is nothing but, if you see, the work produced is area under the curve. So I will draw the area under the curve. So you see B to C, when it is going, this is the area under the curve where you are getting the work. Now if you see here, this is the area only which, how much work is required? This is the area B, C, G and F. That much work is required. But the work produces more than B, C, G, F. That much amount is the more work produced. That means what? Here the energy will be stored by the flywheel. Okay. Now as the energy is stored by the flywheel, what will happen? its speed goes on increasing. From B to C, speed increases. So this is what the area, work done area is. Let us say take any point here. Let us say I na J and K. Let us say. So it is B, J, C, G, F, D again. Okay. So that is what is that area or work done. Now here speed increases. So here speed increases. Okay. Now if I go from C to D, what will happen? So C to D, let us say C to D. When you go from C to D, what happens? You see, work required is C, D, H, G. Work required, I will write short form, work required is area C, D, H, G. C, D, H, G. And what is work produced or work developed? That is the area under the curve. What is the curve now? This is the curve. This is the area. This is the curve. This is the area. So that means the area is, let us draw by this chalk, let us say. This is the area. Let us draw like this. Okay. So that means what? How much is the work required? This much. How is the work done? This much only. That means there is a scarcity of work. So who will supply? Flywheel will supply. That means if the flywheel supplies the work, its speed decreases. So when C to D, its speed decreases. So it is nothing but the area done is C, G, and this is any point. So that will be okay. So here you can say speed decreases. Okay, done. So what happens here? If you see simultaneously, when A to B it goes, its speed decreases. When B to C it goes, its speed increases. When C to D it goes, its speed decreases. From D to E, if you see, its speed again increases. Now if you see certain points, you say from B, its speed start increasing, and at point C, its speed start decreasing. That means B to C it is increasing. Okay. So B to C it is increasing. From C it start decreasing. That means what? C is the maximum speed point. Yes. Similarly, if you see here from D to E, its speed increases, and at E it start decreasing. That means the points C and E are the points where you will get maximum speed. Let us say that maximum speed is Nmax, or you can say N1 also for the maximum speed. Don't worry. Okay. Now similarly, if you see from A to B, the speed goes on decreasing. So A to B decreasing. At the B it is very less. Now from B it is going to increase. That means what? At the B you are having very less speed. That means lowest speed, minimum speed is at B. Similarly, at D you are getting the lowest speed. So here at C and E you are having maximum speed. At B and D you are having minimum speed. So N mean or N2 you can say. Or in angular terms you can write omega max and omega mean. Okay. So now these terms you understand, I think so. So here from this diagram what conclusion we can draw is, here you can get the speed of flywheel increases, decreases. Okay. So that flywheel is attached to a shaft of a motor. That means whatever the circuit or whatever the mechanism is there, it is also one fluctuation of the speed. Okay. So what flywheel tries to do, flywheel tries to minimize the fluctuation of the speed. you see the speed is from maximum to minimum it is going. That means there is a fluctuation of a speed. Okay, so let us take another concept, that is the fluctuation or coefficient of fluctuation of speed. I think you understand this. If you want, you can pause the video and take down notes. So now let us say what is the coefficient of fluctuation of speed. Coefficient of fluctuation of speed. Now we already know what is the fluctuation of speed. Already we have discussed how the speed gets fluctuated. Okay, so maximum one times we are having maximum, one time you are having minimum, like that. So how this coefficient of fluctuation of speed can be calculated? Coefficient of fluctuation of speed generally denoted by Cs and can be calculated as n max minus n mean divided by n average, or n mean. This mean is different, this mean is different, this is smaller. Okay, so you can also write here n1 minus n2 divided by n. What is this? This is average. How average can be calculated? N can be calculated as n1 plus n2 by 2. That is the average of maximum and minimum. Okay. Now you can also write this Cs as Cs comes out to be n1 minus n2 divided by, right here, by n1 plus n2 by 2. This 2 will go up, we will have twice n1 minus n2 by n1 plus n2. You can write this in the angular form also, like twice n1, instead of n1 you write omega 1 minus omega 2 by omega 1 plus omega 2, because you will have n is nothing but can be converted into omega. That is what. Watching the video. In the next lecture or next video we will have the coefficient of fluctuation of energy and very famous derivation for this. If you like my video, please like, share and subscribe. Thank you.